Superposition of pulse. Superposition of pulse is a principle that helps us to understand what happens to the pulses when they move towards each other. Let's say, for example, we have two pulses that are moving towards each other. This pulse is pulse A and is having an amplitude of 2 meters, and the pulse of B with an amplitude of 3 meters is moving towards pulse A. So what will happen to these pulses when they get together? So when these pulses get together, they are going to form a bigger pulse since they both have the positive amplitudes. So that means the amplitudes will add up and make how much? 2 plus 3, which will make 5 meters. So but now, after these pulses meet, they're going to continue to move in their own directions. So the pulse of B was moving to the left. So after the interference, it will continue to move to the left. So that means the pulse of B will be on this side. But now after they pass the interference, it will return to the normal amplitude, which was 3 meters. And this was the pulse of B. The very same will happen to the pulse of A. Since it was moving to the right, it will continue to move to the right, and the amplitude will go back to 2 meters. So they will keep the same direction. This was left and this was right. So now the type of interference when the pulses meet and they form a bigger pulse, it is what we call a constructive interference. So a constructive interference is when the amplitudes add to make a bigger amplitude. So now we can also have two pulses that are in opposite directions and they move towards each other. Let's say, for example, we have now the following two pulses. Pulse of A that is having a positive amplitude of 3 meters and is moving to the right. But now we have a pulse of B with a smaller amplitude of 1 meter moving to the left. What is going to happen when these two pulses meet? So when these two pulses meet, they are going to result in a smaller pulse. Since we have the pulse that is positive and the pulse that is negative, so the amplitudes will subtract. But now the bigger pulse will take the resultant. So now the bigger pulse is in a positive amplitude. So therefore our resultant will be a positive amplitude, but it will be a smaller amplitude since the amplitude of both the pulses subtract. So you're going to say 3 subtract 1, and that will give us the amplitude of 2 meters, which is the amplitude of both the pulses when they meet. But remember, after they meet, they are going to continue in their same directions. So the pulse of B will now move in this direction, and it will have what? It will have the original amplitude, which was 1 meter, and is moving where? It's moving to the left. The same will happen to the amplitude or the pulse of A, which was moving to the right. It will continue to move to the right, and it will return to its original amplitude of 3 meters. And this is A with the same direction, right. So now, when two pulses meet and they form a smaller pulse, this type of an interference is called a destructive interference. So a destructive interference is whereby the amplitudes subtract to form a smaller amplitude when the pulses meet. This is all that I wanted to discuss in this video. Thank you very much.